Hi, Don Cavellis here from Four Dog Stove Company. It's going to be about what I call potology. Well, what's potology? If you got a fire or a stove, you need a pot. And in cooking mostly with biofuels. I prefer to burn wood myself. That's what I do. I make stoves to be burned with wood. One thing we forget, over 2 billion people are still cooking with wood. So it's still a very, very, very widely used, that or some sort of biomass, which could be dung, wood, twigs, briquettes made from paper waste, sawdust waste, etc. A lot of people think this is much greener than using biomass. But now if you look at it here, most of these come from Japan. Japan has no petrochemical industry of its own at all. So the petrochemical they get has to come normally from the Middle East, which is transported to Japan. They have no iron ore industry. So the steel has to be transported to Japan, manufactured into this small tin, then transported back to the United States, then distributed amongst the United States. And out of this one tin, and if you look at 1 acre of woods as you see right here, will provide the user 1 cord of firewood, that 1.5 pounds of twigs, or that 4-ounce canister of petrochemicals. So that's for you to decide. The nice thing with your biomass stoves is that you can burn anything from shit to shinola to cook your meal. Because you got to remember, dung from a herbivore, goat, sheep, horse, donkey, camel, is all biomass, but it has a low catalyst. So you got approximately 6,000 BTUs per 1 pound of material. Isobutane has approximately 19,000 BTUs of energy per 1 pound of material. Alcohol, depending on the type of alcohol, this type, this is methyl alcohol, is about 8,400 BTUs. You go to pure alcohol, you're up to about 12,000 BTUs. Your esbit or hexamine is 13,000 BTUs. Charcoal is about also close to 14,000 BTUs, and wood is 7,000 BTUs. Now what does that mean? It means there's 7,000 BTUs of 1 pound of dry wood material. Calculate that it takes 1% of the energy in that wood for every 1% of moisture. Wood that's been carbonized, in other words, all the moisture, all the volatiles have been taken out of it, so it's pure energy, is twice the amount of energy per pound than your basically dry wood. 1 to 2 people, maybe up to 3 people, because that's what the majority of the people are doing now, and that's where your smaller stoves work in that category. There's probably more people cooking on a 3-stone fire today than any other method. With proper technique and skill, those people can cook almost as efficiently as someone cooking on a regular stove. That's been around since man started cooking. Majority of pots that you found back in that area had a minimum of 1 quart or a little bit more per person. Because if you were cooking beans, rice, food that wasn't concentrated, you needed that volume for that person to receive enough calories to continue on his travails. This pot here is probably more people have seen little pots like this. This was made very, very popular with the Boy Scouts. Came normally in the Boy Scout mess kit that I'm sure anyone that's over 50 years old remembers. It actually had a little bale handle, and it was about a 3/4 of a quart capacity. If we look at this pot set right here, this is a Meta. This was developed by the Swiss back in the 1920s. It was actually manufactured to be utilized with a solid fuel tab. This here could also be utilized as a double boiler. Item underneath, you could also be keeping your first content warm while the other item is cooking. Is what some people call a Kelly kettle, which is basically what you have. You have a spun aluminum, a water encased pot, whereas you drop your fuel inside here, down into your burner. The heat comes up, it heats your water. As soon as it starts to boil or steam, you can take that off and pour that out. A double-walled pot dates back to the Chinese, and that was utilized probably since the 14 to 1500s. All stoves will profit from using a windscreen. There's a lot of discussion and debate, and people will say, well, you know, my stove's so good I don't need a windscreen. You may not need a windscreen, but it means that you have the opportunity to burn a whole lot more fuel because you don't have one. Now on your gas burners, it's not quite so bad because you can just increase your BTUs. You will see your degradation of cooking ability on your lower BTU fuels because you just don't have the output with them. So I would say there's no stove that you don't profit by the use of a windscreen. The first part of the efficiency, how well are we able to extract the energy from the fuel that we're burning? Or how do we get the most of those BTUs? Is how well are we able to transfer that heat by the way that is burning to our actual pot? The third part of it would be the actual pot we're utilizing and how that heat source is transferring heat to the contents of the pot. The best efficiency you can get on that is from about 15 to 30% efficiency. Now, depending on the design of the stove, we can increase that efficiency to 60 to 70%. If we take a look here from the simple tin can bush cooker to our Bush Buddy type stove, which is basically a secondary combustion. You're creating a secondary combustion by having the double wall, which preheats your secondary combustion. You have your primary combustion on the top of the fire grate. You have a secondary combustion. When you see burning, you'll see it almost looks like a gas burner. Well, it isn't actually burning the oxygen. What it's doing, it's giving a secondary combustion of the hot gases being generated, so it's a secondary combustion stove. Now, but you do need that secondary combustion when you're burning biomass to get your best efficiency. This would be an optimum setup right here. We're protecting the flame source from the outside atmosphere. We're keeping that contact with the pot for a considerable amount of time before it leaves to the atmosphere. We're using on the same principle as the Trangia stoves. The quickness of burning, how fast you're able to cook, it's just so much superior. Half of this amount is 16 ounces. That's the minimum amount of moisture that we need to cook a meal to give us good gut satisfaction. Good gut satisfaction would be approximately the content of this bowl, which is approximately 16 to 20 ounces. And that's what a person needs, 16 to 20 ounces to have good gut satisfaction when they eat. It is still found the U.S. military did extensive study on how to come up with the lightest, most efficient ration for their special operation troops. But what they found, that if people didn't have one good meal a day, which comprised of about 16 to 20 ounces of volume, their psychological well-being broke down so much that it hurt their effectiveness. Canteen cup is approximately 750 cc's or approximately 22 ounce capacity. It's approximately 800 cc's or approximately 24 ounces. Tight fitting lead, nice wide base, folds very compact. Snow Peak 900, there again, a little bit bigger, closer to 30 ounces. We're staying within that around quarters of a liter to 22 to 24 ounce capacity. It also allows the person when using a biomass stove to whereas they can pick it up, feed your stove. Pick it up, feed your stove. When you start looking to go to for winter, late fall, then I would say you want to go to something that's at least about 2 liters or close to it. The reason being you're going to have to melt snow. When you're melting snow, it probably takes a run of 2 to 3 times for you to get 1 liter of water. One of the largest causes of injuries when camping is scalding. So we must make sure we provide for our own safety. Aluminum's good if it's hard anodized. The reason I say that is hard anodizing does 2 things for you. It seals the pores of the aluminum, doesn't allow for food to stick as easily. Aluminum's great for transfer of energy, and it's lightweight for the same thicknesses. It also tempers that aluminum, so it's as strong as stainless steel for the same thickness. Titanium has its limitations. I like it. Do you have to have it? No. But I can get extremely lightweight because I can go thinner, because the properties of titanium allows it to take the heat better and the abuse better for the same thickness than, say, aluminum. But point view for just a nice, lightweight, durable pot that'll take the heat and take the abuse, I don't think you can beat titanium. I know people that use that same setup who are on fire crews that are out for weeks on end fighting wildland fires. They need things that are robust, can take a lot of damage, and work. My go-to pot for winter use would be the Morris pot, or if I've got more than one person. I've cooked up to a week for 2 people just using the Morris pot. I find this setup here is quite efficient when burning your solid fuel tabs. I think all your pots need a lid. I mean, without a lid, you lose so much of your energy to the atmosphere when you're cooking. But I found by having the one hole, it allows me to know when my pot comes to the boil because of the steam escaping from it. And as far as straining my pasta, it's not that hard just to shift my pot a little bit like this. And you can see here, I can drain my pasta plenty good without having strainer holes. I like these for the simplicity of it. I find when I burn them in a bush cooker type stove or like a bush buddy type stove, they're really efficient and they're fast. I can take 4 of these tablets and I can bring a liter to a boil in my bush cooker stove in under 5 minutes. And you can produce your own charcoal in your bush cooker type stove by burning the wood until the flame's just about out, spread it out on the ground till it goes out, or you could put it in a can with a tight fitting lid, put it in there, seal the lid. You've made your own charcoal from wood in the bush. I take 1 ounce of alcohol, pour that over the top, light it. It'll sit there and bring a liter to a boil, which gives me my pot of coffee, within 8 minutes, and then it'll give me an hour's cook time. So I can bake, fry, do any sort of other cooking for a little over an hour before the charcoal runs out. If I do 32 ounces, I got enough to make my tea or my coffee, and then I have enough liquid left to cook my evening meal. So by the time you've got your hammock or your tent set up, you've got a hot brew. But the nice thing with the biomass, I can bring, like say in a bush cooker, tin can bush cooker, or a bush buddy type stove, I can bring my pot to a boil. And now without adding any more fuel, I'll still have a 7 to 10 minute simmer time and longer than that of an actual cooking time than I would have with the other fuels. Now, once the water that's evaporated, actual food has absorbed the moisture, the heat source has gone down so far, I'm not going to have to worry about burning or scalding my pot, even when you're losing a thin titanium pot. The advantage of using the charcoal and the biomass is that you also receive a simmer time afterwards that you don't get from the propane, alcohol, or the hexamine. All I have there is ash that I can throw into the wind and actually acts like a little bit of a fertilizer in a bush cooker or bush buddy type stove, which I feel is a great advantage. Point view pot size, like I had stated before, I would go to a minimum of a 3/4 to a 1 liter size pot for 1 person. 2 people, at least 1.5 liters to 2 liter size. You're never worried about the fire you're burning, you're worried about the next fire. So I would always have fuel harvested for my next fire. Can my cooking pot fit inside my pot? I mean, one of the most popular stoves available today would be like the Bush Buddy. It fits the pot. Check my website at 4dog.com, and I hope to see you on the trail. Thank you.